thank the GT Institute of Management Studies and Research and the group that has considered me worthy of conducting a webinar for everybody who's available or who's attended here. And I would also like to thank everyone who's joined this webinar to learn what I have to share about cloud computing. Before I get started, brief introduction or a brief background that I have with working with cloud infrastructure and businesses, big businesses, solving problems for big businesses with cloud. I have 7 years of work experience working with data engineering, data science, and machine learning problems. And I've helped businesses tackle some of their key problems using big data on cloud and data science technologies. Today, I want to give you an overview of what cloud computing is. I'll try to walk you through how cloud computing is used and why it is necessary for us to know about cloud computing and the businesses it operates in and the opportunities that are available with cloud computing technologies. Without further ado, let me get started on the presentation. So I have named this cloud computing a bird's eye view. At the end of the session, I expect people who are not very technologically involved with cloud computing to have a vague sense of what cloud computing means. It's a very vast subject of study. It is, I don't think anybody can become an expert in 1 hour of learning cloud computing. And I also, I don't intend that to be the intent of this webinar. This webinar is mainly to give people an introduction into what cloud computing is and what it holds for the future. Now, what is cloud computing, right? I think the first time I heard about the word cloud computing was when I was in school. This was about 15 to 20 years ago. It was a buzzword back then, but now it's become a reality where I have started to work with some of these technologies myself. Cloud computing. So what do we want to discuss in this webinar? I'll be talking about what is cloud computing, the technology. What is cloud computing, the market? Meaning, what are the business impact of cloud computing? How much investment is going into cloud computing? And what are the opportunities for us as individuals to get involved and take advantage of this trend that is taking all industries in a big way. So I want to structure this webinar in a way that I will give introduction and introduce some concepts, do a recap, pause for about 5 minutes, see if there are any questions. Then I will continue again with further concepts, take a pause for questions, and then we will end up, we will end the session in about, I think, 40 to 50 minutes with more questions at the end of the session, right? Let's start. Let's try to understand what is cloud computing. If I were to understand cloud computing, the first thing that I would do was go and look up Google and search what is Wikipedia telling me about cloud computing. Wikipedia, the largest online encyclopedia, states cloud computing is on-demand availability of computer resources, especially data storage and computing power, without direct active management by the user. This definition is is a pretty mouthful. Let's try to understand a little bit deeper what it actually means through some examples. Yeah, let's look at some examples. Cloud storage. For us to understand what cloud computing is, I think we can understand a simpler usage of cloud, that is cloud storage. Cloud storage, if you've used any of your email services, that is Outlook, Gmail, Yahoo, AOL, Rediff, etc., or if you've used online storage, if you have an Android phone, Google Photos, if you are a person who's working with companies which share data across different organizations, that then you would have come across Dropbox, and anybody who has a Gmail account has access to Google Drive. Right now, let's revisit the definition. So what is on-demand entail when we talk about email and online storage? The user can use these services whenever they want. There is no, the services are available all the time. The user does not have any active management involved to store or organize this data, right? It means the information that you're exchanging via emails are stored in data storage services by your email providers, and it is made available to you, the end user, via network access, that is the internet. The on-demand availability used in the definition that we are looking at is the data storage for email and online storage. Let's look at cloud compute, right? If you've used any of the video streaming services, that is YouTube, Hotstar, Netflix, you've used cloud compute. What do I mean by this? So we just now we analyzed what it is, what it means to access cloud storage. Let's take a look at cloud compute. So storing video on a remote data server would count as cloud storage. If you add the ability to view that video, that is a software which can play the video and which can connect to the internet and play it at the time you want and help you navigate to any point in the video. That is what you do on YouTube, right? You go onto YouTube, you're able to search for videos, you're able to play and pause whenever you want. And all of these activities, the interaction with that you're having with the video data is controlled by software. And to run the software, you need some computing power. That is basically a simple use case of cloud compute. Now, if I have to go back about, before I move on to characteristics of cloud computing, I just want to give you an appreciation for how far cloud computing has come along, or give you an appreciation for where cloud computing started, right? It started with cloud storage and video streaming services. YouTube started in the year 2006, and emails, I think, have been roughly around for about 50 years or so, with the first applications for email being used for military applications. Having said that, if we were able to do all of this in 2006, now it is 14 years later. This is 2020 now. So how far has cloud computing come along? That is something that I want to touch upon in the future, in the coming slides. Before we move on, let's look at some of the characteristics of cloud computing. Some of the important characteristics of cloud computing is shared resources. Cloud computing uses resources from a pool of IT resources available over a network. What does this mean, right? What are IT services? IT services, resources, sorry. IT resources are servers, network cables, email servers, data storage facilities, website hosting facilities, which are available, which enable somebody to create an online process or an IT presence, right? The second characteristic of cloud computing is network access. You should, the assets that you have with respect to computer hardware and software in terms of IT resources should be available to end users via a network. A network could be private or it could be public. We will touch upon more on public versus private in later stages, but to quickly give you a sense of what it means, if you have ever used a network or a laptop inside your educational institution, or maybe software which only works within your office, that is your private network access. Some of the softwares and some of the applications will not be allowed to use outside that network, and anybody who is outside the network will not be able to access that particular software. That is called as private network. Public network is the internet that we all access freely on our phones and on our computers day in, day out, right? Now, coming to the third characteristics of cloud, rapid elasticity. What does rapid elasticity mean? Let's say you are in IT infrastructure requirements increase as time passes. The ability to quickly increase or decrease the number of servers that you use, the number of cables that you use, the amount of network usage that you have, as per your need, is a key characteristic of cloud computing. So anything, to summarize again, you have shared IT resources which are available over a network for the end user to use. You have a network access where you can log in and use the IT resources that were available, and rapid elasticity. The third point is basically giving the user the ability to increase or decrease the amount of resources that they will be using as per their need. Now, what would happen if rapid elasticity, or what would happen to businesses which were not on cloud, which did not have rapid elasticity as the key characteristic, right? So before cloud computing was the norm, or I think cloud computing will take some time to become the norm, but of late, before anybody worked on cloud, how did they cater to their IT infrastructure needs? So these big technological companies, or any companies, any businesses that have a requirement for technological processes to be set up, required to invest in physical space for data centers. What are data centers? Data centers are a collection of your computers which enable you to store, access, and share data about your business or about your processes. For example, if I have to take an example of Jio as a business, Reliance Jio has, I think, about 200 to 300 million users in India. So if you have to keep track of how many users are there, what is the billing cycle, how much revenue is getting generated from each of these users, how much infrastructure in terms of using their mobile phones, using their network, how many calls they're making. All of this, if Jio had to do it on their own, they would have to invest in data centers which had the infrastructure, the computers to store this data, this amount of data. They would have to invest in hardware and in software. Now, if you've ever worked with a laptop, you know that laptop gets heated up every time you process a lot of information. If you're running a heavy duty software, something which is used to probably, if you're an electronics engineer, or if you're a design person, you would have used software which is heavy on your, or even if you played games on your laptops or your computers, you know that the system heats up, right? Because of if you imagine the scale of data centers, the amount of heat generated by data centers is immense. So they have specialized cooling systems, which is air conditioning systems, which are designed specifically for data centers. So this would mean the companies would have to invest in air conditioning systems as well. Now, if you have to increase your capacity, that means you need more physical space, you need more cooling systems, you need more servers and more hardware, and you need labor workforce to set up all of this for the business in order to scale. But what this key characteristic of rapid elasticity completely does away with the requirement for any physical procurement needed by businesses. This is one of the key features that make cloud computing very appealing for big businesses today. Let's do a recap of what we've looked at so far. What is cloud computing? Cloud computing is on demand and always available. That means the end user can use it whenever they want to. There is no active management by the user. The users do not need to worry about hardware or software that runs the IT infrastructure. And how is this achieved? This is achieved using shared resources, internet access to the shared resources, and rapid elasticity. I'll quickly move on to what are the building blocks of cloud. So the first thing that you need is commodity hardware. What do I mean by commodity hardware? Commodity hardware is what comprises of your computers. It is your RAM, your ROMs, which hold and run the softwares, right? Then you need an internet, you need a network which is connected to these commodity hardware, and this is provided to the end user using a remote access. And that's, if you have these three basic elements, then you are set to have a cloud infrastructure for your cloud infrastructure setup, right? Now, what are some of the key technological innovations or technological enhancements that have driven the adaptation of cloud, which are driving the advancements in cloud, right? Some of the key technologies that drive the growth of cloud computing are as below. Higher processing power at cheaper rates. So Gordon Moore, he's the co-founder of Intel, stated the following about microprocessors. Moore's law, it's called Moore's law. It states that the number of transistors on a microchip doubles about every 2 years, and the cost of computers will be halved in the same time. What this means is you have more processing power at cheaper and cheaper rates. And this has been true for microprocessing for the last 6 decades, that is the last 60 years, right? So we've come a long way in terms of computing power. If you've studied basic computers and large frame computers in your previous education, you would have you will see that computers went from occupying rooms full of space to, even a phone today is a mini computer in your pocket. So that is the amount of processing power that is available to us today. The second key technology innovation that has driven cloud computing is virtualization technology. What is virtualization technology? Virtualization technology was developed in the 1960s to enable multiple users to access the same hardware at the same time. I will talk more about this in the coming slides. The key thing to understand or identify here is that virtualization technology enables users to access the same hardware from multiple devices, right? Now, open source operating systems. Open source operating systems are free operating systems. These are the, this is a set of instructions that help your hardware run, that help your software interact with your hardware. And they're the open source part of it means they're developed for free for everybody, and you do not have to pay anybody to use them, right? This also has more implications in terms of the development of the software, how rapidly it can evolve, and how people can innovate, because you don't have to be part of an organization to actually contribute to these softwares. You can do it sitting at home from your own, if you have an access to a computer and an internet network. Open source software or open source operating systems have been key drivers for the virtualization technology, which is again very important for cloud computing to operate the way it does. The fourth process, the fourth key technological innovation that is driving growth for cloud computing is automation. What does this mean, right? If we go back a couple of slides, we discussed how getting infrastructure procured for new users was difficult because of physical labor involved. With bigger data centers and bigger or improved technology for processing, we are able to translate some of this work which is done by manual labor into software, which does it in a matter of seconds for end users, right? So if the impact of this, basically automation and virtual technology play into the key feature of rapid elasticity that makes cloud computing extremely appealing, right? How does it happen? So if you have requirements for 3 new servers with 4 new storage accounts that you need, all you need to do is interact with the software on the cloud, and the software does it for you. It will identify the resources that are available. It will identify the software. It will identify the hardware it is available. It will identify the network which is connected to the hardware, and it will connect your applications to those hardwares automatically without involving any person in between, right? So this is very powerful, which actually helps the elasticity characteristic of cloud computing. Now, let's discuss some more about virtualization, because I think virtualization is one of the most important technological advancements that has driven cloud development and cloud adaptation. So virtualization, as I mentioned, was developed in the 1960s to give access to multiple users to same computers. If you look on the left side, we have hardware, we have an operating system on top of the hardware, and we have applications running on this. If I have to give you an example of this, if you think about your CPU as your hardware, your RAM and ROM as your hardware, the Windows software operating system on your software, and your Excel, Microsoft Word, your Winamp player if you've used it, VLC players, your Google Chrome application. These are the applications that run on the operating system, which is interacting with the hardware. In the traditional architecture, if this entire unit had to interact 1:1, what do I mean? So if there is a soft operating system that is available, all the applications the end user can use applications on one operating system, and the operating system can interact with the hardware. Now, if somebody is using the hardware, if somebody is using a physical computer, it does not allow for anybody else to use the same physical hardware. You can think of a scenario if you're in a computer lab and somebody is sitting on a computer. You need access to all of the tools that the person is using for you to access that computer. By this, I mean, you need to have the access to the keyboard, mouse, and the software, and for you to use it. That means two people cannot occupy the same space on the computer. What virtual architecture does is it enables users to use the same computer from two different places, right? Two different users can use two different softwares on the same hardware, and this is done by the virtualization layer. Some of the key virtualization softwares that are available today, and some of the key companies that are working on virtualization software, is VMware, Red Hat, and these are the two main players. And this enables the end users to have something called virtual machines, which I will discuss later. So to give you a summary of how virtual architecture works. Virtual architecture basically divides the access of the operating system to the hardware. So if you include a virtualization layer, you can have multiple operating systems and multiple softwares interacting with operating systems on the same hardware. This is the key impact of, or this is the key utility of cloud computing that is being used by big businesses today. Let me discuss about give virtualization another example. If you had three different purposes earlier, let's say you had an email server, you had a web server for your website, and you had your Excel, Word legacy apps that were running. You would have to require two different or three different machines to run these softwares and applications independently. But with virtual architecture, you can divide one server into three different parts and have all of them run on one, while the third server is completely free to be used by somebody else. So this is making efficient utilization of the same available infrastructure. Now, what all can be virtualized, right? As of today, you can virtualize your desktop. All of the Indian IT companies that work for foreign businesses work on virtual machines. What does that mean? Sitting in your office or sitting in your home, you connect to a computer which is hosted on a data center in a completely different part of the world, and you can access the desktop software and run your applications on them, right? This is what enables work from home, and this is what has been the main reason that IT industry is the least impacted by the current COVID crisis, right? Because you don't have any dependency to be close to the computers that you're working with. You can do that sitting anywhere with just access to the internet, right? It also means you don't need access to a very powerful system. All you need is a very powerful internet connection. If you have to play a game on your desktop, the hardware should support the size of the file. The graphics have to be supported by the graphics card on your computer. Your RAM should be able to process all the instructions that you're sending to the game, and the game is processing at the same time. But if you have a virtual gaming station, you don't necessarily need to do that. All you have is to log in into a server and you play your game online. And all of our online games, be it Dream Circle Fantasy Cricket League or the Fantasy Football Leagues, you have all of these coming in via this virtualization software, right? So this is desktop. Desktop virtualization is the key driver for work from home and remote work policies. Application virtualization is what we discussed with respect to games. Network virtualization is basically using the same network hardware that you have. You will have network cables, you will have network routers, you will have network switches, which will direct traffic between different systems and different environments. You can use the same network infrastructure to run more than one network, right? This is something called as network virtualization. You have similarly storage virtualization. I think storage virtualization is what we discussed with video streaming services, and server virtualization is the example that we saw in the previous slide, right? Let's do a quick recap of what we discussed in terms of the basic building blocks of cloud computing, and what are the technological advancements that drive cloud computing, that are driving the growth of cloud computing. The building blocks is basically you need to have IT resources which are shared in a network, and you need to have the key technological innovations that are driving cloud is basically processing power, virtualization, open source operating systems, and automation. One key aspect that I forgot to discuss earlier is the impact of open source softwares when it comes to virtualization. If you have proprietary software, it becomes very difficult for proprietary software, or it is very easy for the company which is making the software to make it in such a way as to not interact with other hardware. What do I mean by this? The biggest example for proprietary software and hardware is the Apple devices. If you know Apple devices, you know that the Apple devices do not interact with different Android applications. You need a specific the Bluetooth on Apple does not interact with Bluetooth on Android devices, for example, right? So companies can use this as a lock-in. The technical term is called vendor lock-in, which basically prevents the user from moving away from their own application. So that means if you start using Apple devices, it is very difficult for an Apple user to move to a different platform, because everything has to happen on Apple hardware and Apple software, right? Now, this is about one individual user. Think about a business. Businesses have to interact with multiple softwares and helping different business functions. You cannot have a limitation like this holding up holding up collaboration between systems, right? This was one of the key hurdles that open source operating systems helped overcome along with the virtualization layer, right? So that is an important distinction to note, and an important point to note as to why open source played a big role in cloud computing. Now, moving on. We've discussed what is cloud computing, what are some of the key technologies that are driving cloud computing. Let's see how cloud computing is used, right? Cloud computing is mainly used in three different ways. One, as infrastructure as a service, right? The second one is platform as a service. Third one is software as a service. What does this mean, right? I will discuss infrastructure as a service with an example. In infrastructure as a service, the end user, most likely infrastructure would be used by a business, big business. So big businesses will acquire infrastructure needed to run their workloads, to run their workloads for their business. Let's look at an example, right? The example that I'm talking about here is Netflix. Netflix, for those of you who are not aware, is a video streaming company which is 23 years old. It started in 1997. It is worth about $100 billion today. Netflix originally started as a website which was renting out DVDs, because DVDs were the talk of the town in the that was the trend in the 1990s, and Netflix started renting out DVDs for a subscription fee, right? As technology advanced, Netflix realized that DVDs are no longer relevant, and in 2007 they started something called as Watch Now, which is an online streaming platform where you could watch the videos you were renting earlier, right? In 2007, this was set up on Netflix's own data centers, right? But in 2016, Netflix completely migrated to AWS by abandoning their own data centers, right? Let's look at what workload was being spent on the Netflix rental business. This is before the streaming era of Netflix. Basically 6.3 million subscribers was the growth that you saw, that Netflix saw between 1997 and 2006. And majority of the activity that was happening on their website is customers going and browsing for the DVDs they want to rent, and the DVDs and the transactions recording a customer renting a DVD, right? It's at the end of the day, it is textual information, it is numbers. It's something like a Word document. If I have to give an analogy of media, it is like storing a series of Word documents on your servers, right? Netflix did this on on-prem servers. Fast forward from 2007 to 2013, Netflix went from 6.3 million subscribers to 44 million subscribers. That is a 7-fold increase. The number of users increased by 7 times over a course of 4 years, right? This is the user, this is the increase in load because of the users, right? Let's discuss what is the increase in load because of streaming. Now, earlier, all you have to have is information about DVDs that you want to sell. Now, from 2007 to 2013, what Netflix was actually doing was storing these videos on their own data centers and streaming them, making them available to end users whenever they wanted. So they had to stream data that was stored on their networks to outside end consumers, right? during this phase, Netflix did this using on-prem plus cloud servers. If I have to take an analogy, or if I have to recall the example of acquiring physical systems, you can imagine the amount of computing power involved. If you work with a Word file versus a video file, you know that video files are orders of magnitude larger than a video file. So the transactions that you were recording earlier, if it was X, you're probably dealing with 10X or 20X when it comes to, or even more than that when it comes to video. I think it's probably in the order of 100 to 1,000 times in terms of processing and storage needed for that. So having to go from transactions and image data to streaming video data is an extremely ambitious endeavor, and Netflix struggled between 2007 and 2013. You can read about this online, and I encourage users to read about this online, because it gives you it gives you more appreciation for how cloud enabled Netflix to grow exponentially, right? Fast forward 2013 is when Netflix migrated completely to the cloud. That meant all of their data was hosted on cloud, all of their software was hosted on cloud. Customers were interacting with infrastructure not owned by Netflix. Netflix used somebody else's infrastructure to run its business. Now, Netflix in 2020, they have 190 million customers. They went from 6 million at the end of 2006 to 190 million. That is 35 times what they had 15 years ago, right? And they're dealing with more transactions, they're dealing with more browsing behavior, they're dealing with more streaming behavior, and all of this is happening on cloud. What this means is, let's say there is an outage there's a power outage for 3 days in one part of the country. Netflix servers will cut down because those many servers are not being used for streaming anymore, right? That way it helps save costs for Netflix. Along with this, Netflix, along with the feature of just providing streaming, Netflix also has recommendations that come along with if Netflix basically learns, becomes more intelligent about what you like as a user, and it will start showing you the content that you're used to seeing more often, right? So this is done by running algorithms on the data that Netflix has stored about you. So what sort of data is Netflix storing about you, right? So every movie that you've ever watched, every pause that you've ever made on Netflix, or all the movies and the TV shows that you've browsed, you thought, okay, I'm interested in probably watching this in the future. It gives you, it looks at all of this content and it matches this with some of its own behaviors that it has seen with other users, and does some computation to tell you what you might like in the future, right? So this is, if I have to roughly say, Netflix is, for the 190 million customers, they interact 10 times over 90 days, right? Over a period of 90 days, if all the 190 million customers interact just 10 times, Netflix is processing close to 19 billion interactions. And this is just one click per customer, right? So you can imagine the amount of data that is being stored and then being processed to give you relevant information, right? So for a business to grow, it needs more IT infrastructure, it needs more processing power, and it needs different kinds of tools to run its business. All of this is provisioned on the AWS server by Netflix. This is a very well-known case study for cloud computing, and Netflix is one of the key, one of the pioneers in adopting cloud computing for their own business, and they've went from in the last 20 years, they were able to create a wealth of close to $100 billion because of this. If I have to, I think if I have to convert this, it closely translates to about 70,000 crore rupees, or probably even more than that, right? So that's a lot of value that you can generate by making the right technological choices. Now, moving on, we will discuss the second use case, that is platform as a service. Cloud platform as a service is used by most companies to run their data workloads, and how we just discussed the machine learning algorithms which understand patterns of user behavior, and recommendation systems in terms of AI, artificial intelligence softwares, right? So who are the key providers of platforms? You have Microsoft Azure, Amazon Web Services, Google Cloud Platform, and the IBM Cloud. All of these vendors provide tools to businesses to create their own applications and software as per their business needs. Businesses can now experiment with their own applications without having to invest in platforms. So this is something that I've seen as a hurdle for businesses to improve their processes and experiment with their business. So this basically helps, or using cloud as a platform helps business users get everything ready for their, let's say somebody has to experiment with respect to, let's take the example of Geo again, right? If the Reliance folks had to make a decision about which markets to enter first, they probably need certain softwares and hardware to manage the data that they're generating from Geo. Instead of investing in a physical data center, you can invest in a software application to understand this behavior in a matter of minutes using the cloud platform, right? Now, Google Cloud Platform is a key example for services that it provides. It provides big data services. Google was one of the pioneers which helped develop big data as a technology and open source it to the world, so it is freely available for other businesses to use. They provide with different compute infrastructure. You need different kind of compute for running your data workloads. You need different kind of compute for your web hosting. You need different kind of compute for, let's say, if somebody needs to create an animation, right? You need very powerful machines to render those images. And if somebody has to run a mobile application, he needs a different kind of compute. So all of these are available on the Google Cloud. Development tools are available. Identity and security management is available. Machine learning is basically for your pattern recognition, and data analysis is available. Management tools, basically how do you set up the hierarchy of access rights? You don't want everybody accessing every system on your platform, so you need management tools to have a control over who's accessing what. And then you have your networks. You have virtual private networks. You have your own cloud network. If you want to create a private cloud, you can leverage some of these tools to build one. And then you have your databases which store your data, right? Moving on, software as a service. Most of us have used the Microsoft Office software. This is your Excel. This is your This is your Word document, the PPT that I'm sharing right now. All of these is applications or softwares that are available. How do you make a software available as a service? This is exactly what Microsoft has done by making Office 365. Office 365 is all of these softwares bundled together and made available on the internet. What this enables us to do today is basically interact with the same document. If, let's say, four students are working on the same project and they want to collaborate on the documentation for that project, they can do it with 4 different systems and they can work on a single document today. If business users are working on a presentation for a sales deck, they can all independently work on the same PowerPoint presentation that they will take to the end user, right? Now you can interact with each other. You can work together on Teams, on video calls. This is what has been driving cloud behavior or cloud. This is what has been driving work from home behavior and made it easier for IT professionals to engage with their companies during the COVID crisis, right? Before the COVID crisis started, there is a software called Slack, which was the leader in team collaboration softwares. Post that, because Microsoft is already entrenched in all of the big companies, Microsoft has pushed their own softwares, cloud softwares, basically Word, Excel, and Teams, to collaborate together, and they've seen significant amount of growth in the last 6 months. Imagine when most of the businesses are failing because of COVID crisis. There are some businesses like the Microsoft Office, which is actually benefiting a lot from a crisis like this. This goes on to advocate the utility of the cloud platform and the cloud computing softwares as a whole, right? Another important mention that I want to make here is about an open source animation software, which is called Blender. This is a software which is available for free, and you can use it to create your cartoons. You can use it to create your designs, graphic design. You can use it for VFX effects. You can use it for motion detection, motion capture videos, etc. And with when you have something like an animation to be rendered, it takes a lot of computing power, right? A normal laptop or a normal desktop cannot handle the amount of processing needed to generate scenes and to generate cartoons and to generate video sequences. What Blender has done is made this software, the rendering part of the software, available on the internet for free. Small correction, it is not available for free. It is available for a subscription. The Blender software itself is free, but the renderings, the cloud infrastructure, which helps the Blender software and interacts with it, is a subscription service that you have to pay a nominal amount every month to utilize, right? This way, creativity is being democratized. People with very less amount of investment, or the barrier for entry into animation when probably I was in school to what it is today is very less, because of companies like Blender.org, which are open sourcing, creating their softwares and open sourcing these softwares and making them available for users to use and pay only for the key or the heavy workloads that the users need to accomplish, right? This is another very interesting use case. I encourage listeners of this webinar to go ahead and look more into this ecosystem of Blender. So does this mean everything is good with cloud and there are no disadvantages at all? No. Let's discuss the advantages, and then we will look at the disadvantages of cloud. High scalability. This is something that we've discussed continuously through this webinar. That is, infrastructure can be improved as demand grows. Pay as you go. You only pay for the infrastructure that you are using. Going back to the example of Netflix, if Netflix loses, let's say, half of its business today, it will not continue to pay higher infrastructure costs for all of its 190 million users. It'll pay only for the 85 million users that will still continue to use it, right? Easy experimentation, no hardware requirements or no hardware procurement is required for when you're interacting with cloud, right? Better backup options. If you're one of the biggest, in my experience of 7 years on the data engineering and the data science side of things, is when you don't have backup options for your data, right? This is a big risk that needs to be addressed, and backup strategies were earlier prone to hardware issues, network outages, software issues on on-premise clusters whenever somebody had everything within their own network. With cloud, better backup facilities and options are available for companies so that they don't lose their data. Easy collaboration across teams and geographies is something that we discussed with the Microsoft Office example, and low or zero maintenance. This is, I think, one of the factors that we haven't touched upon a lot. It's the maintenance cost that I discussed with the cooling of the air conditioning that is required for big servers, and the labor expenses that are involved with maintaining huge data centers, right? So these are some of the advantages of cloud. What are the disadvantages of cloud? Vendor lock-in, right? If all of the software or all of the business processes are involved in one cloud, it becomes extremely difficult to move this software outside of the cloud. So you become heavily reliant on one single vendor. Limited control. You have limited control over how a particular cloud infrastructure is being procured, which specific network is being used, what is the security protocols in place, etc. The third and the biggest concern about cloud is if the cloud gets exposed to attacks by hackers or malware, all of the data and applications on that particular cloud is at risk. Cloud becomes a single point of failure for most of these. We've been seeing data leaks on iCloud. We've seen data leaks from Facebook. A bunch of them have happened because of security concerns that come with having data on the cloud, right? Now, downtime. If a lot of users, if a lot of companies decide to use cloud computing in one particular region, to a very large extent, there will be outages that are common, and that means you will lose access to some of the infrastructure that you've procured for some time. So these are some of the disadvantages. In order to balance the advantages and the disadvantages that we saw right now, companies use different strategies to encounter, to reduce the disadvantages, or to reduce the impact of disadvantages, and take full advantages of the pros, right? So these are some of the cloud strategies that are used by businesses. That is called public cloud. Public cloud is your Amazon Web Services, Azure, and Google Cloud Platform that we discussed. Private cloud is when you have, actually let me discuss private cloud with an example so that it is more clear. Hybrid cloud is when you're using public and private as a strategy to host your cloud. And multi-cloud. Multi-cloud is when you're using more than one cloud service to run your business. Now public cloud. So public cloud means your infrastructure, your network, and your access. All of this happens via the internet, and this is available on the public cloud provider. The private cloud is when the IT infrastructure and the network is behind a firewall within your own organization. Somebody outside of that network cannot get access to this cloud, whereas the people inside the network will have full access and will have the full flexibility of the private network. This enables users to have more security control over their processes, right? Hybrid, let's look at the hybrid infrastructure. Hybrid infrastructure is when you're using probably a part of the service, the IT infrastructure, or you're using a public, you're using private infrastructure on a public network or a public infrastructure on a private network, right? This is implemented for mostly security reasons and cost reasons. Some companies might prefer to have their own data centers interacting with the public cloud and public cloud network and their storage. Hybrid infrastructures make excellent choices for backup strategies, where all of the internal data is, all of the transaction data is probably updated within their network, and the cloud is used just as a backup service, so that if in case anything happens with the internal network, you always have a backup on the cloud, right? So let's do a quick recap of what we discussed in terms of the different ways cloud computing is used today. The infrastructure as a service, we discussed the Netflix example. Platform as a service, we discussed the Google Cloud example. Software as a service, we discussed the Microsoft Office example. We also saw what is a public cloud, private cloud, hybrid, and multi-cloud. We did not discuss much about multi-cloud because multi-cloud is basically using two public clouds at the same time. To simply put, that is what multi-cloud means. All right. So we have so far discussed what is cloud computing, what are some of the key technological improvements that have driven cloud computing growth. We have also discussed how cloud computing is used by businesses today. Let's look at the market, right? When I say market, how much money is being put into cloud computing by big businesses today. This is Gartner forecast for cloud computing. For those of you who do not know Gartner, it is a global research company which advises or which generates reports on technological trends, market trends across a variety of verticals: supply chain, technology, computer software, data visualization software, artificial intelligence, etc. Right? Gartner Magic Quadrant is considered one of the key indicators of how the technology trends are shaping up around the world. Now, if you see, we discussed some of these key uses of cloud, that is infrastructure as a service, cloud application as a service, platform as a service. There are two other services that are being accounted for in the Gartner forecast. All of these numbers that you see are in billions of dollars. So as of 2020, the anticipated forecast of now the amount of investment that is seen in the cloud computing space is $266 billion. This translates to about 1.5 lakh crore rupees, right? And if you analyze the rows across all of these, there is no trend that is decreasing. All of these numbers are increasing from left to right. That means all of these businesses are growing from the last 2 years, and the forecast is that they'll continue to grow. If we are at 200, it is forecasted to grow at a very high pace as well, from 260 million in 2020 to close to 360 million in 2022. That is $100 billion on top of what is already being spent in the year 2020, right? So this is one of the key indicators of where cloud market is going. There's going to be a lot of money being put into cloud by a lot of businesses around the world. Let's look at actually what is happening with one of the providers of cloud. Right? Here I have the market cap, or the stock price of Microsoft since its inception. Microsoft started in 1986, and it started with $0.1. And you can see the trajectory of Microsoft up until 2014. 2014 is when Satya Nadella took reins of Microsoft, and he puts the focus on improving their cloud services, right? And then you see the growth that you see after 2014. In the last 6 years, Microsoft's valuation has, or the net worth has gone from $330 billion in 2014 to $1 trillion in 2019. This is threefold increase in the last 6 years, right? So this is again a very very good indicator of how cloud has had an impact on the business. We've already seen Netflix over the last 20 years building a $100 billion business by making the right technology choices. Now Microsoft, one of the key providers of cloud, you can see the impact of their investments in cloud on the numbers that they're earning, right? I want to take one more example here is of Amazon. Amazon, for the majority of their e-commerce journey, have been a non-profitable or a loss-making business. When they moved into AWS, the Amazon Web Services, is one of the key businesses that is driving revenue for, that is driving profits for Amazon. You can see this is the data between 2016 and 2019. For the first 6 quarters, Amazon Web Services Amazon Web Services had more profits than the total business. That means it was not only making profits, it was making up for the losses in the e-commerce and the other investments. Now, even after the other investments started paying dividends for Amazon, Amazon Web Services still accounts to be close to 50% of the profit that Amazon is making year over year, right? Or quarter over quarter. Now, this is how big the market for cloud computing is. Now, all of this is fine. Cloud is very good technology. There's a lot of money being put in. Why should you and I care about it? We should care about it because cloud computing is offering a lot of jobs. The cloud computing jobs are the cornerstone of the job market since the COVID crisis started. When millions of people have been losing jobs across the world in different verticals and different businesses, the demand for cloud computing jobs has seen significant and consistent increase over the last 6 months, right? I have the screenshot from today about open positions in cloud computing jobs in Bangalore. I see 6,000 openings as of today morning, right? This is a screenshot that I took from Naukri.com today morning. You can see 6,000 jobs which are still vacant, right? At my own organization, Tredence, demand for tech expertise in cloud and hiring for cloud has not stopped. We are seeing this is again something which is actually doing better when everything else is failing, is something that you need to get behind, right? And the jobs are not just in one area. Cloud computing jobs are completely widespread because of the different kind of functions that they perform. Let's say you have network requirements, so you need network security. You need infrastructure requirements, so you need infrastructure management. You need developers who know and can interact with these systems. You need data engineering expertise on cloud for people who want to build their data systems with if you want to build an app for a business, if you're a website and you want to build an app for your business, cloud computing makes that easier, right? So you can get a job in a variety of these different roles, right? So the other aspect of this is startups. If you're somebody who's not interested in working for somebody else and you want to start something on your own, cloud computing startups are the rage, right? There's a lot of investment that is, again, with most of the startups losing investment during the COVID crisis. Cloud computing startups are one of the key areas which have continued to attract funding since the COVID crisis started. The areas of these startups include cloud security, data science, artificial intelligence, location services, pattern recognition systems, design software, to name a few. Now, okay, we understand that cloud computing jobs are vacant right now. There's a lot of opportunity for somebody to get into cloud computing. How does somebody go about getting involved in cloud computing, right? One way to go about it is via certifications. Google, AWS, and Azure all provide certifications for gaining expertise on individual on their platforms, and companies pay top tier salaries for certified professionals who know these technologies really well and who can talk the language of cloud, who can understand the processes of the cloud, and who can work hands-on and work with these components which are changing continuously and will continue to grow in the future. Certifications for some of us might be might have a barrier of entry because you have to spend a decent amount of time to go and get these certifications done, and then you also have to spend some money to pay for the certification exams. For those of us who want to get involved without the certifications, there is always open source. Open source is free software that can be developed by anybody, and they have and open source technologies. The source code for all of these technologies are available online, so you can go and look at those softwares. You can read about the software. You can write your own code. You can submit your own code. What this does is it also gives you visibility with the wider network of developers all over the world who are developing the same software. It also makes you it gets you exposed to the developer community all over the world, which is developing some of the most impactful softwares, which is driving the biggest business decisions today. So open source is another way to get involved in cloud computing. For people who want to learn these platforms like Google, AWS, and Azure, the components of these platforms, online learning via online learning on Udemy, Coursera, Simply Learn, Edureka, or some of the key online platforms that are that host lessons and have practice exercises for these cloud platforms, and they help you prepare for these exams as well. So if you're interested, you could go look up that course and you can do some. This will be extremely helpful for students specifically, because you have time on your hand. You're sitting at home. You cannot really go outside and do much. So you might as well sit and look at these courses. If something interests you, pursue something there, and you might even make a very good career decision by moving to cloud because of this. So we've discussed what has happened in the past, what are some of the things that have driven cloud to what it is today. Let's discuss what is the possible futures that cloud computing can realize, right? I think one of the key announcements that has been made in this year by AWS, if I'm not wrong, is about quantum computing made available on the cloud. This means an order of degree. This is again a big leap in the processing power, which is being made available to businesses and end users in terms of processing. We have the Internet of Things. Internet of Things is basically when you have the most simple example that I can give you is, let's say you can control everything, all the electronic equipment inside your house via a phone app, right? You can choose what things to turn on, what things to turn off. You can choose your washing machine to run at a certain time. You can choose your internet to be turned off, right? All of that from a phone. That concept is called Internet of Things, where every electronic device is connected. It does not necessarily have to be every electronic device. It's basically a network of electronic devices interacting with each other and making decisions on their own. Data science and intelligence systems are some of these are the recommendation systems that you see online for e-commerce, on e-commerce websites, etc. Virtualization is something we already discussed, and this is going to cause more disruption in the technology space, and everything on cloud. Everything on cloud. What do I mean by everything on cloud? It is when all of the businesses across the world invest enough so that they have a majority of their workload happening on the cloud, right? So the future for cloud computing is actually the present and the future for cloud computing seems to be exciting and seems to be a good place to be in, right? On that note, I wish everybody all the best. I hope you learn something from today. I gave you some new information. If you have any questions, I would like to take those questions now.